Hello, my name is Bolaji. I am a PhD student in the Department of Civil and Environmental Engineering at the University of Rhode Island. I will be giving a poster presentation on the topic, efficient strengthening of concrete cylinders using additively manufactured Auxetic TPU metamaterials. The goal of this project is to compare and contrast strengthening design strategies based on the condition assessment of concrete cylinders. The idea is to first conduct the numerical simulation using Abacus CAE. Then we go ahead to using 3D digital image correlation for our validation of the result from the Abacus CAE. The big picture of the project is such that we have our auxiliary cylinder. We know that when we push our auxiliary cylinder down, we expect the cylinder to shrink further inward because of the auxiliary behavior. However, a concrete cylinder, when it's being pushed down under a uniaxial load, compression load, we expect it to widen transversely. So the counterintuitive behavior of the auxiliary cylinder is going to reduce the dilation of the concrete, thereby pushing the concrete further inward and creating even more reinforcement for the concrete. So before we went ahead into the simulation of the auxiliary cylinder as it creates the reinforcement for the concrete cylinder, we went down to the unit cell of the auxiliary cylinder. The unit cell of the auxiliary cylinder is a reentrant honeycomb unit cell, which has 4 geometrical features. And the features are vertical cell length, slant cell length, cell thickness, and cell angle. We varied these 4 geometrical features and we generated geometries using Auxetic Python code on Abacus scripting, and we got 8,096 Auxetic geometry datasets. We went back to pull back the 8,096 Auxetic geometry dataset into Abacus CAE so we can apply our displacement loading of 20 mm. So on each dataset, a displacement loading of 20 mm was applied on one side while keeping the other side constant. After the final element analysis was conducted, the strain values were computed, and ultimately the Poisson's ratios were gotten. Poisson's ratios were gotten for all the 8,096 datasets. With all the Poisson's ratios that we got, we went ahead to carry out a machine learning explanation of the results of the displacement loading that was applied on individual datasets. So we took all the input feature of the unit cell, or all the 4 geometrical features of the unit cell as input features for a machine learning, and the output feature was Poisson's ratio. We went ahead to conduct SHARP analysis. So SHARP is shapely additive explanation from game theory that helps us to understand what's happening in the black box of a machine learning model. So from the SHARP analysis, we discovered that slant cell length was the input feature that affected the most the evaluation of the Poisson's ratio, down to the cell thickness, which affected the least in the evaluation of the Poisson's ratio. Then we ran also SHARP violin. SHARP violin helps us to determine how much of the Poisson's ratio were determined, which are negative by the slant cell length. So the first line shows a huge bulb of blue, which explains that a large quantity of the Poisson's ratio gotten are negative and they're affected by slant cell length. After completing the machine learning implementation, we came up with an optimum geometrical feature combinations for the auxiliary cylinder. So we went to SolidWorks to model the auxiliary cylinder using the optimum geometrical features that we got from the machine learning implementation, and also modeled the concrete cylinder, then imported files into Abacus CAE. We conducted a damage analysis for the jacketed concrete cylinder with Auxetic TPU cylinder, ran our analysis, and came up with our preliminary result. So our preliminary result shows that for just a high strength concrete under uni-axial compressive loading, that shows a catastrophic failure. On the other side, for a high strength concrete that's jacketed with Auxetic TPU, we have a non-catastrophic failure. So the delay time that is obvious in the high strength concrete jacketed with the Auxetic cylinder helps to give a warning during a failure in a civil structure. Then we intend to conduct a 3D DIC, digital image correlation, on concrete cylinders with Auxetic TPU jacket, so we can understand the out of plane deformation of the concrete cylinders as they are affected by the Auxetic TPU jacket. We also understand that the dilation of the concrete is going to change, which is ultimately going to change the effective Poisson's ratio of the assembly of the concrete cylinder and the TPU Auxetic cylinder. In conclusion, the result of the Poisson's ratio of the digital image correlation analysis compared to the final element analysis when we were generating a large data set was less than 3%, which gave us a confidence that is high enough to say that the data that we generated or the geometries that we generated can be dependent upon. Also, the Poisson's ratios are developed to form a predictive model for the auxiliary behavior of reentrant honeycomb TPU structures. So the model that was generated enabled us to come up with an optimum reentrant unit cell, which enable us to create a good auxiliary cylinder. This present study is present an efficient strengthening method using the Auxetic TPU metamaterial. Thank you.